So thank you everybody for joining another Rockwool R-Class Roundtable. My name is Chris Caparucio. I am the Key Account Manager for Builder Development here at Rockwool. I'm joined by Nick Stone, our residential architectural specialist. Sorry about that, Nick. And then our guest of panel made of guest builders. I'm sorry. Familiar face, Travis. Travis, do you want to introduce yourself?
I'd be happy to. My name is Travis Brungard. I am a partner at Catalyst Construction. Myself, along with my business partner Joe Cook, build new custom homes as well as high-end renovations in the Kansas City market.
And then the first of the two Randys, Randy Williams. How are you, sir?
I am well. I am in northern Minnesota. I am a recovering general contractor, now the editor of Green Building Advisor.
Thank you, Randy. And not other Randy, but Mr. Randy Rand. Also a reoccurring face on these roundtables here.
Yeah, it's been fun. I'm glad to take part in it. Randy Rand, I'm out of Orono, Maine. We're a contractor up here building high performance passive house, design and build. Yeah, up in a climate zone 6, and it's great. We also do training and education statewide for builders and code officers. So yeah, glad to be here.
Well, thank you guys for joining again. Obviously not your first rodeo, so thank you for continuing to join these and get out there and talk to people about some of this stuff because as we were talking about behind the scenes, this is a bit of a complicated topic when you're talking about roofing systems and the different ways to go about it. Not that there's a right way, there are good ways, there are better ways, there are just ways. So thank you for being willing to dive into a topic that's a little murky. Before we get into what we're actually going to talk about today, I wanted to just put this slide out there as something that we offer, or I guess some things that we offer. These are 3 different guides or papers that we've published. They're on the Rockwool website. You can download them in PDF form. They are primarily or largely commercially focused, or I mean, there's some industrial applications as well, but it's more commercial products and applications. And to that end, they talk about some of these products, which we will not be really talking about today, though you could probably interchange some of these for the applications that we're discussing. We have Top Rock DD, Top Rock DD Plus. There's a tapered product with flute filler. I mean, again, these are more commercially driven or commercially focused, but we are going to be talking about a little bit of that comfort board usage and application today. So I just wanted to put these 2 slides out there because we have a lot in the roofing space, and in the residential side, we don't really hear much of it. But out in the commercial and industrial worlds, it's not something we just dabble in. It's something that Rockwool as a company is kind of on the forefront of, and it's a big portion of our business. And I don't know that this group knows that it is as big for us as it actually is. So I just wanted to put that out there, that there are more I guess avenues for information than what we're going to show today. This will be exclusively residentially focused, but these are other products that you could use. Was that something, Travis?
Yeah, can I ask, Chris, is it possible for a residential contractor to access these commercial solutions? I've had applications where some of these might have been tremendously beneficial. In fact, you did hook me up with some flute filler on a job where I needed it. So I know that as a residential builder, I have applications for these. Can I get them?
That was supposed to be a one-on-one discussion that we had there about that flute filler, but
Sorry,
yes,
Chris.
yeah. Yes, you could of course always buy these products. Like I said, they're primarily currently utilized and spec'd in commercial or industrial applications, but it just takes a few more steps to find the right distributor and get, up-to-date pricing and see where our production capacity is at. I mean, they're when we make roofing product, you make them by the hundreds of thousands of square feet. So it's just less common for the factories to run those product lines. But yeah, of course, anybody could go get this product. It's just they're different distribution avenues, and
Sure.
we'd have to kind of steer you towards the best
As
option
long as
for
I
you.
need an entire truckload full, you'll get it to me.
Sure, sure.
Maybe not. I was
It,
just reaching
no,
because
no, it's an option. It's a good question. They're products that we don't really see on the residential side, but you could absolutely go get them and use them for residential applications. Yes.
there's so many contemporary designs that utilize flat roof systems and a lot of these same solutions that the commercial community's been working through for a long time. There's a lot of applications, so it's good to know that you guys have these solutions. I wasn't trying to get you in trouble, Chris. Thanks again for
No,
letting me
it's a
know.
fair question, and you probably did get me in trouble, but we're okay. We're all right. We're gonna keep going. No, you didn't. It's fine. Really, you can go get these. I wouldn't show them if they weren't available. It's okay. It's
That
all right.
makes sense. Sorry, buddy.
No, it's all good. On that, what actually constitutes a roof? And I think AI Travis is thinking about that right now. Is it just something over your head? Is it as simple as an umbrella that's keeping the rain off? I don't know. AI Travis seems, he's thinking about it. He's just weighing his options. What actually constitutes a roof? Are there any immediate thoughts? Is it as simple as that?
It's close. I mean,
Real Travis?
Real Travis agrees with AI Travis. And I like the tan on AI Travis, by the way. I got to get more time in the sun, maybe lose a couple pounds too. But I will say that the thing that separates a roof, specifically in my mind, from a different type of outdoor enclosure is that the roof, typically in my market, I look for overhangs. I'm looking to just shed water. It can be open on the sides. I have a roof over my covered front porch that's open on all sides. Well, I
Hmm,
guess not the house side. You know what I mean? It's
sure.
open air. The roof is as simple as an umbrella in my mind, whether it's part of the thermal and vapor control layers as well or not, is immaterial. It's definitely a water control layer, and it typically terminates open-ended, at least on a couple of sides.
It's as good an answer as any for now. I'll take that. Do you guys have anything that you want to add to that before we get into the meat and potatoes here?
Nope.
No? All right. Nick?
All righty. So as we start to think more about what is a roof, let's take a look at some of the needs of a roof. So one of the big needs is sun resistance. It's constantly being beat on by the sun. It is what protects us from shade. It gives us shade, protects our what's inside of our home, kind of around our home. Oftentimes with overhangs, bulk water management, as Travis just mentioned, is a huge component of the roof itself. Outdoor temperatures are another one of those things. Everything from hot temperatures down to freezing cold temperatures. They kind of have to battle all those different areas. When it comes to style options, there are so many different options that are out there. We were all joking here before everything started. The butterfly roof is certainly something we see up here in New England, right, Randy?
Hmm.
But no, depending upon where you are located, design of the roof could play a very large role in how we look at, where we're going to place our building, what it's going to look like. To me, something that pops out is shed roofs, trying to take on some more solar gain, overhangs, and certainly on some of these buildings. I'm a huge believer in as well, Travis. I think overhangs are tremendously important. And things like you see some of these hip roofs where the one roof line intersects into another one, which intersects into another one. So the way we kind of design these roof assemblies, is going to impact how that roof performs year after year. Material of these roof lines and how we're picking them, whether it's from a two by framing, I joist. We do a lot of I joists here in New England where I am, because we're looking for thicker cords for snow load. Randy Williams, you're in that same category where, a lot of what we do is 60, 70 pound snow load, and we have to make sure we have the structure for that, which pushes us even into the realm of LVLs, when we're really looking at some of these ski areas, and also glue lamps. If you're looking for some aesthetics, some beautiful decorative beams, whether it's something like a Douglas fir, that's just, you could oil up and kind of leave exposed. There's a lot of options when it comes to roofs, how you can look at them, how you can view them. Um, Oh, you have the control on your side. Go to the next slide. We have a new platform, so we're still kind of working out some of these kinks here. But you're also looking at different loads like wind uplift, gravity, impact. So when we start looking and thinking about roof assemblies, there are just so many variables that we really have to plan for. Air control, vapors, a couple other ones. Uh, Now, when we're thinking on your projects, maybe I'll start with Travis. What are some of the loads that you're kind of, in your area considering, thinking about, and really planning for?
Well, we certainly have uplift concerns in our market. We're not coastal, obviously. We're in Kansas City. We're right in the middle of the map. But some would call it Tornado Alley. So uplift and wind loads are a real thing that our structural engineers are designing for. So that's certainly a concern. And then we do get all four seasons. So snow load is something that, or the gravity load, as you've got it listed there. We experience that, and we get the joys of hailstorms. So impact load. I guess I'm 3 for 3. We love it here in Climate Zone 4. I want to make sure to make Nick Stone true and honest in all of his speeches.
Yeah, absolutely. Now, as we move further north, let's start with Maine. Randy Rand, what are some of the things that you're designing for and thinking about?
One of the big things we're always thinking about is that snow load obviously is pretty great up here. But then our biggest thing personally that we kind of focus on is shading. So using our roofs to shade our windows to in the summer times. That way then we can plan and optimize that solar heat gain during the winter. So we're paying close attention to that shading opportunity for us. Yeah.
That's a good point. I didn't even think about that. Yeah.
Now, Randy, what kind of loads are you? So when you say snow loads, are we? I know in Maine you can get quite high. What kind of loads are you thinking of?
So our last project was about 90 pounds.
Ooh,
So yeah,
Wow,
yeah. So it depends on which
that's
which part of the
yeah.
state we're in, but yeah.
how many feet of snow is that when what to get to 90 pounds? What would you need? Do you know? Just
Uh,
just offhand, not to put you on the spot.
yeah,
How
no
light's
idea.
the snow?
Too much.
We could. I
Too
was gonna
much.
say, are we getting slush with that or
Yeah.
uh,
All right.
so
No, it's a lot.
yeah, yeah.
Absolutely. Now, Randy Williams, when you start talking Minnesota, what are we talking? I got to imagine it's pretty similar to Maine, maybe even more snow load.
Depending on where you're at, it can be, yeah. But typically we're in that 70 pound. Some areas might be as high as 90, depending on where they're at. You get next to the big lake of Lake Superior, you got maybe some lake effect snows that we're dealing with. And there we have some wind as well that we have to deal with. So again, we're covering all the same stuff. Even depending on who the designer is, we'll get that solar heat. Um, the overhang, just like what Randy had mentioned, configured in as well. But that's a little bit more rare in my market. It's mostly just standard overhangs. We'll get a 2 foot overhang and we'll get some shading, but not as much as maybe what we would want some areas, especially in the summertime.
So I have to ask here, when you're talking about everything that goes into these, the climate zone seems to drive a lot of this design. What are the elements that we're dealing with? Clearly, on none of our roundtables thus far throughout the year. Now they weren't focused on roofs, but this really hasn't come up when we're talking about design and what the client wants and how you're incorporating performance into these houses. I mean, how big is uh, and I ask because look at the header on this slide. Like performance and protections do start at the top. We always talk about build a strong foundation, don't let things crumble, prepare yourself for rot and mold and moisture. But this sounds like you're dealing with quite a bit at the top of the structure. How big of a conversation point is this during design?
It's substantial. I know our friend Jake Bruton is always talking about that's the first page he turns to in a new set of plans before he bids the job because he wants to know where the water's going. It's like I don't want to bid a job that's going to put me in a lawsuit, and so if we don't have good roof design, I'm not interested. And if we're not going to change the roof design to make it a good roof design, I'm not interested. So I think it comes up more likely or more often than not. On our projects, we seem to have an awful lot of people seeking vaulted roof assemblies and
Okay.
very low profile fascia lines. So I don't want to jump ahead, but that's something that will come up, I think, again and again in terms of roof design, because oftentimes those things will be paired with a low slope metal roof, which is kind of a nice timpani drum. So it gets into one of the other benefits of the Rockwell product. We get a lot of sound attenuation in our roof design, but it definitely comes up in the design conversations. And before we can permit a job, we've got to be compliant for our values, and that
Hmm.
usually has to do with rafter depth and other things. So yeah, it's definitely part of the conversation.
Randy Rand, I saw you nodding. I mean, is that, yeah?
Yeah, like Travis said, and it's always the first thing we kind of look at because bulk water is the most important thing. And so we're always looking at valleys, any side dormers or places that roof's dumping onto our walls, even, and we're not kicking that water out away from walls or dumping it above windows. So we're really paying attention to the roof pretty extensively. And with a lot of the stuff that we kind of try to focus on in the high performance world is simplicity, right? And that's what can really help us make things last longer, be more durable. So if we can, just get like a single pitch roof or even, uh, a standard double pitch or something, that tends to be where we lean. However, right now I'm dealing with a house that has a very complicated roof. And it is one of the things that when you get into that situation, we have to spend even more time up front pre-planning those situations. So, um, because we want to protect ourselves, right, as builders.
Yeah.
So
Yeah, of course.
that's where I think it sees the most abuse out of any part of our house, and we got to just make sure that what we're doing there is not causing problems elsewhere. In addition, so
No, that
yeah,
makes sense.
I would
And Randy
also
Williams, when we
It,
talk about like green building advisor and just green building in general, is there a lot of content being created around, I guess, around the roofing system? I mean, is that a key focus? Because I'm thinking energy loss, heat rises, and also there's the sun, so heat's beating down on the top of your house. So I have to imagine this is a bigger talking point when it comes to just energy in general. No?
yeah, we have a on the site on Green Building Advisor, we have a forum area where people can come in and ask questions. We have a few experts that'll chime in. I'm one of them that'll help if we can. And one of the most common questions is on roofs. It's do I need a vented roof? How do I insulate my cathedral ceiling?
Hmm.
And I always go back to the same thing. Like what Randy said, the simplest. Keep it simple, and everything else follows with that. It's just if you have all those roof lines trying to get the air control correct, your insulation correct, it complicates so much of it. Yeah.
And I would also, add in there, how much time do you guys add? Maybe you do, maybe you don't. But working with mechanicals on how many penetrations you're going to put through that roof, because I would have to imagine that might be a big deal. I see some head nods. Randy Rand, what do you think on that one?
we just spent about 4 hours today walking around with our plumber and our trades guys talking about that exact thing. And, you know, they want to try to put up three vents for the plumbing system. And it's like, well, how can we avoid that, right? We want to avoid those penetrations. So we really spend quite a bit of time planning every one of those types of things. And then even pre-planning for, future solar systems, make sure that
Mhm.
we're putting in roof junction boxes so that those are all waterproof correctly and work with our system. So we do those site walks, and they're super important.
That's really interesting. Pre-planning for future systems. I actually would never have thought about that until right this second. That's a fantastic idea. I like that idea a lot. Makes a lot of sense. Now, Travis, what about you? I saw you got pretty excited when I said eliminating some of those penetrations.
Yeah, it's a constant battle. I mean, you guys know he's a regular guest on this webinar. My business partner, Joe Cook, is a master plumber. and he has done all sorts of impressive gymnastics to get plumbing vents through the sidewall and out underneath the eave to where we are still code compliant, but we don't have that risk of water infiltration at the rooftop. Um, we tend to move our clients toward electrification simply so we don't have to have flue pipes going through roofs. Um, Frankly, a lot of our appliances are moving away from combustion anyway, so that's easier solved. But generally speaking, any hole in the roof is a bad thing. Uh, Trying to reduce skylights where we can. I mean, just anything that is going to be repeatedly challenged with every freeze thaw cycle. Because obviously we can flash the hell out of everything. I mean, we can seal it up and keep it from leaking for a time, but it does become a maintenance item and it can be potentially problematic.
Right.
Because
Yeah.
you're generally dealing with a lot of temperature change at those openings. You know,
Absolutely. Why don't we take a look at one of your projects and let's actually talk about what you did? Because when I started looking at this project, I don't think I saw a single penetration going through that darn roof. You did a good
right.
job.
Yeah, we're lazy. We don't want to do any extra work up there. We just want to go ahead and get everything simple. The idea was to get the plumbing vents through the sidewall. We had a very minimal overhang on the east side of a tall face. I think it was only 18 inches for a section, so it was very easy to just extend our sidewall plumbing vents out to accommodate that. This house has three Mitsubishi low wall heat pumps. Excuse me, ductless mini splits. They are heat pumps, but anyway, the point is that we don't have any flue gases to exhaust. We don't have any combustion appliances in this home. So we were really just trying to solve for plumbing, and I believe we were able to do it without any holes in the roof, if I remember correctly.
I was looking through the videos earlier today, and I think you had zero penetrations. You guys did awesome. And also want to point out, look at this sweet picture I got of you off the video. You're like slamming your hand down, like, yeah, I love rock wool.
That's right. We were playing slapjack on the roof. I don't know if you guys are as good at slapjack as I am, but I have an aggressive slap, and the comfort board is there to minimize the auditory experience of that slapjack dominance.
That's that seismic load that we're referring to.
That's right. Guilty as
Uh,
charged.
yeah, but why don't you talk us through a little bit? Because, when I think about, looking at, roof lines, to me, this isn't something that I would initially be like, that's a roof line, so you just don't see it as common, right? But it works, and that's the important part. So why don't you
Yeah.
walk us through your thoughts behind why you chose to go this method, and then
Sure.
kind of what you did?
Yeah, this was born out of mid-century modern design. Typically includes lower slope roofs. You know, more of your McMansions and Tudors and some of your other architectural styles really rely on the 14 and 12, 18 and 12, at least a 12-12 roof pitch to decorate the elevation and really show mass with the roof. That's not really a part of prairie style or uh, well, mid-century is what this was intended to be. So with these lower sloped roofs, you're not trying to present as much of that to the viewer, and as a result, you can do some really creative things. This one, this was entirely born of the idea of, hey, we would like to get uh, a lot of our value in this low slope without making a really fat fascia, because architects and clients alike, they despise these enormous chunky blocks of roofline sitting on the edge of their house. What they want is this nice narrow clean line that's in keeping with the rest of the architectural appeal of their home. And in order to achieve that, when you have a vaulted roof assembly, you generally are faced with some real challenges, and a lot of people tend to address those with either an elaborate truss or a blown attic and a higher, I guess you'd say, basically a false wall above your plate line. You can do a lot of different framing gymnastics to make this work. The thing that we wanted to do was make our air sealing our top priority, and that makes having that exterior sheathing to roof connection really, really important to us. Once that's solved, then we can create that narrow roof line with this overbuilt framing that you see. This is a basic ventilated overroof. This was, I think, the first one that we did, and I really was excited about it because it solved so many problems for us. It allowed us to basically go, two in, one out with these ladder frame soffit extensions. that our framers built basically like you would build a wall, just laying out on the deck of this 412 roof. And then with those built, we could use comfort bat in the bays and move that thermal boundary out even a little bit past the wall, just so that we didn't have any thermal loss above our structural roof deck. And then you can see that the rafters then go perpendicular to what would have been the structural rafter of the roof below. That was done specifically for speed. We were kind of trying to prove to everyone that you can do an overframed, a ventilated over roof with very little labor. And we framed this whole thing and installed it and sheathed it with 6 people over a day and a half. The framers did the ladder frames for the overhangs in the previous day. And then once we started insulating, we had the framers right behind us sheathing. And it was all one day finished. Now we did have good quality help, but in order to do that quickly, we wanted to minimize cuts. So that's the purpose of, well, the purpose of going perpendicular is twofold. We also limit the thermal bridging from the 2x6s that are standing up, running perpendicular to the roof edge. Those are only creating a thermal bridge with the rafter below over that 1.5 by 1.5 inch square at every rafter connection. So it's not continuous. And so we were able to, with those, 2/3 in and 1/3 out soffit extensions of the 2x6 coming in that, I think it was about 6 feet. Then that acts as a rim. We laid down comfort board, 5-inch comfort board 80 across that roof deck and did not cut it at all. Just fit it tightly together and then slammed the next 2x6 tight up against it, toe-nailed it into the rafters below, which we'd already marked on layout, and then laid in the next row of comfort board. And that made it so that we really only had one cut for every single run at 24 inches, which obviously the comfort board is available in 24 by 48 inch lengths, makes it easy to handle because it is 5 inches thick. It has some weight.
Sure.
But that allowed us to do only one cut at the valley, and then we just started with the next piece. That one cut would be flipped over and be the next piece for the next run, and we would come back and, I mean, as fast as you can throw them down, you can lay in the next board and nail it off. So this was incredibly effective in both speed and cost to achieve the high R value assembly with the vaulted ceiling inside and a really durable roof, because everyone knows a vented roof is one of the most durable ways to address that. And it also offered some resistance to acoustic performance, which on a low slope roof with a metal roof, it's kind of a timpani drum up there, and we do get hail here. So there were a lot of reasons to do it, and that was the longest explanation ever. Sorry to commandeer the webinar.
No, it was good. You had a question that I think you tackled. It was how did you secure the over roof framing? You said you toenailed them.
Correct. Our structural engineer did specify 2 toenails at every rafter connection, and that 3.5-inch nail is all is required.
When you build a system like this, is that you suggesting it? Is it the architect? I mean, where's it coming from? And would you do this again?
We would, and we have. We are on our 4th or 5th ventilated over roof now. For every custom house that we've done since this one, we have all but once been able to get the client on board with it. The architect will get very excited if you explain to them that they can have that narrow roof profile, because you're just utilizing that cantilevered section to establish that. And as long as you're not trying to go greater than 4 feet, a 2x6 is more than adequate. And actually, I think you could even go to 5 feet if you reduce the spacing. We were 16 on center for these ladder frames at the overhang. But if you went to a 12 on center, you could actually go as much as 5 feet. So if you need big overhangs, this is a great solution for you. And it allows your continuity of air control to be tremendously simplified when you're talking about an exterior strategy, which we were on this. So the architect was very excited at this idea that we came up with. And once we saw how they were enthused about the aesthetic, it was easier to get future architects on board, because you can then show them the picture and be like, well, we could do it like this. This is really easy. We're really good at it this way. And then they're like, oh, I get that narrow fascia profile. Like, yeah, 5.5. Oh, I'm in. So if that is your approach, is to appeal to the architect, the only thing that is a concern then is usually your clients go, oh, that looks expensive, because aren't you building 2 roofs? And that's a legitimate question. However, if you if you look at the cost of that secondary roof, the main thing that you're worried about is labor. The materials are not grossly expensive. They're like you can use commodity OSB for either one of these roofs now, um, because your top roof, I would definitely use commodity OSB in most applications because it's sort of sacrificial for us. We're in a market that uses a lot of composition asphalt shingles. It's going to get re-roofed after a hailstorm every 15 years. So making that outer roof an air control layer as well isn't really beneficial. The under roof, we use a lot of zip system, and so that would be a different application. But in terms of the over roof materials, the most expensive thing in it is well, it's either the labor or the rock wool. It depends. But even the rock wool is pretty affordable because you've taken that labor down so much to where you're basically doing one cut for every, what is that, about 1,200 square feet in a run, and one cut. I mean, it's so fast. You have to factor in the labor side, and then all of a sudden it becomes very appealing and cost effective, especially to achieve a ventilated roof, because this is a vented over roof. It is still going to have all the benefits of a very, very tiny attic.
And a question just came in about that ventilation aspect. It
Yep,
said that you mentioned it was ventilated. If
correct.
the plywood is laid right on top of the picture that we're showing there,
Hmm.
where exactly in that system is the venting channel?
So in this picture, again, this was our first one. So the ventilation here would have been slightly less because we would have had the comfort bat at the edges.
Mhm.
What we've done since then, we actually have laid furring strips over the top of the insulated section before
Okay,
sheeting it to create a 3/4 inch gap. I don't think we did that here because we originally figured we were going to use comfort board everywhere, and comfort board is only 5 inches. So we had a
right.
half-inch chute above. Well, I mean, it's available in a number of different thicknesses. We chose the 5 inch, and we had a 5.5 inch framing member. So we had that continuous half inch of venting there. All of our subsequent roofs, at this stage, it became obvious it's a huge performance upgrade to just add that 3/4 furring strip. We used a 1x3, just top nailed it. You notice the alignment of those ladder frames at the soffits is the same. So it's just a straight run. It takes about another 30 minutes to nail off about 800 square feet of that material. And then you can sheathe over that. And now you have a continuous 3/4 inch gap that goes from the low side of your roof to the high side. We've done that particularly at ridge detailing. And then we just use a little core vent at the back side of our fascia to let the air in. It goes across the back side of the roof deck. This was our least vented of our ventilated over roofs, but most everything that we do is vented more substantially than this one.
I know you said it was the longest explanation ever, but I'm pretty sure everybody appreciates it. I mean, the details matter. They do. And that's why we're highlighting a project that it's real world application. It's not we're not making it up. It's not fake. This is real. You guys really did it. So thank you.
Pleasure.
I
I'll send you
I
some
would
fresh pics that have the other details so you can share them with people if they want them, because we've got 4 other roofs since this one where we have done the furring strips, and it is really stupid simple.
I like it. I wanted to transition from this explanation to another application that's very different. It was done very differently. And Randy Rand, I'd like to give you the floor here because again, you're dealing with similar uh, weather systems. You're dealing with similar issues up there, but you did a very different system.
Yeah, we approached this. This was a retrofit, and but we did much like Travis did. In our biggest focus was that air control layer, and so we chopped off the existing roof, right, and pulled the overhangs off it, and then we were able to make that continuous connection from our walls to the roof, and that's what you can see in the lower left-hand picture. There is that our roof membrane, air barrier, moisture control actually went right down our wall with no overhangs. And then we've applied comfort board over the top of that. So in our case, we had 2 layers of 4-inch comfort board.
Randy,
Um,
real quick, when you say you
yeah.
chopped that roof off, can you kind of walk us through? Because in my head, I'm like, whoa, you ripped that whole entire roof off? but
Yeah,
I
yeah.
don't think that's quite what you did.
No, that's not. Yeah, good catch. No, we chopped off the overhang. So we all they were trusses that were made on this existing house, and the tails of those trusses we chopped off to create what I like to call the monopoly house, or the industry's calling them the monopoly house look. So, that perfect rectangular house with no overhangs is the easiest way to achieve that air barrier. So underneath that SIGA membrane, we have the existing roof deck. So we had 1/2 inch CDX plywood. That was the existing roof deck on this house. So that all remained, and we covered it up, and then just laid our comfort board over the top of it. And
Yeah.
in our case, we didn't put down any of that, the framing directly to framing, like Travis achieved. So with his middle section of his roof that he explained was essentially our entire section. We could take just the comfort board, lay it down. We had cuts on the end, and that was it, right? So you could really fly on this roof, and this roof was just a 412 pitch. So we were able to lay this entire roof and comfort board probably in half a day, right? And that was 2 layers of 4. So we've got about 8 inches of insulation up here. So super simple, easy way to do it. Easiest way I can think of to achieve insulation in a cathedral ceiling like this. So
Can you talk about fastening? Because that was the reason we
yeah,
didn't do this. I was scared as hell I was going to blow out the side of my trusses with long lags. So tell me how did you slay that draft?
so that was one of our biggest worries too with this one. Um, and this was a personal project, so it was easy for us to explore these options with it, because I knew if something went wrong, then it's on me, right? So this is great. But that was exactly one thing that we're worried about. So what you can see is, to achieve our venting in this case, we laid 2x4s on flat, and then screwed through those into the structural member in the existing roof, right? And we were using like a 16-inch screw. Okay. So first common thing that we worry about is I've got to hit that 1.5 inch space down below. Um, we took the time and marked everything out really well ahead of time. And I would say that after we drove a screw every 14 inches on these 2 bys, we probably missed about 5%. So the
Wow.
success rate I felt was way better than what we were worried about. When you do drive them and you do miss, so it's not like any question. Particularly in our case, we had just that 1/2 inch CDX that was that roof deck, so that screw would grab that CDX and just kind of, you could feel it not grab. The important piece was that we leave that fastener in place and not pull it out and try to reset it. So that way we're not penetrating, we're leaving that whole plug that we made in our air barrier. So that was the important part of it. But
Now, Randy,
the
take that a step further, because those
sure.
were not just any fasteners. This is where I fell in love with a certain fastener was on this project, and I have probably promoted this maybe 1,000 times on projects. I think that this has really changed my thoughts on over roof insulation with this fastener.
Yeah, so we used I believe they were Hecco screws. Hecco, I believe Hecco was the manufacturer on the screw. And they have threads down where they're lagging into the structural member, and then they have a smooth shaft, and then a thread again up where they're gonna sit into the 2x4 that's on flat. And the idea, what the way these screws work, is that when you drive them through both, that is what's transferring the structural load into from the furring strips down through the insulation and into the structure of the house. The screw is doing that work. It's not relying on the comfort board that you're pressing against, right? So yeah, they were super easy. You know, my biggest fear, like Travis said, was hitting that structure below. But yeah.
Yeah, I really like, especially when you're talking to those heavier snow loads that you were up in your area. Just when I got up onto that to the roof and I just checked out how sturdy those really were, it really blew me away that that strapping, that 2x4 locked in place with the combination of everything going on. Because when I first thought of this, I had my concerns that you would get compression
Mhm.
and because of the snow load and all the other factors are heavier than the walls. But those fasteners in combination really dialed it in. And I was pretty excited when I saw those on your project.
It does require the extra step. You've got to make sure that they're specified and they're engineered for your loads, obviously, and your roof system and the amount of insulation that you've got. So it does require that extra step. It's not just a prescriptive method. Hey, throw one in every 14 inches. They do have a design to go through, but yeah.
Similar question to what I asked Travis. How did you land on 8-inch thickness? Like, how did you land on this design? Because this is not
So
what you drive down the neighborhood or down the street and you see on every house. How did we land here?
So this was a bit of a balance between what we could achieve for insulation within the structure below it, and then what we could get on the outside. And with these roofs, we're really trying to meet that 50-50 exterior insulation to interior insulation, our value. So that's where that put us on this roof. And get it to close. I can't remember what it actually adds up here, but we're close to I think a R75, almost R80 on this roof, and with what's inside. But that's was our goal. I mean, we were trying to get this to a passive level, and that's how we felt we were going to get there. So those initial thoughts and parameters that we set are really what drove the choice of material here. So
Can I
So
make
when
a
it,
can I make a quick comment?
Please.
yeah.
So that 50-50 ratio that Randy brought up, that is climate dependent.
mhm.
If you're in my climate zone 7 or 8, that no longer applies. If you're in Travis's or south, that it's even less that you need above. So it is in the codes. That my area it's 60% above the roof deck, so we even have to have more. Yeah.
And Randy, and that's also different for the wall. So even if you're in that same zone, the wall ratio is not the same as a roof ratio, correct?
Correct. It's quite a bit more on the roof than it is on the walls. Yeah.
Absolutely. Well, now that you've chimed on in here, if we go to the next slide, why don't you kind of work our way through hot roof versus cold roof? But first, check out that picture. Isn't that a cool picture? This is Travis's grandpappy was building this light years before he ever thought of it.
This was pulled
The only
from Green Building Advisor, wasn't it, Nick?
uh no, I think it
It
was
wasn't?
somebody else. I
Okay.
think it was Fine Home Building.
Oh,
Uh
okay.
the only thing that Travis's grandpappy didn't have right was skylights, right?
If they're done right, I got no issue. Keep it, carry on.
But no, Randy Williams, if you wouldn't mind kind of walking us through, what is a hot roof? What is a cold roof? These are terms that get thrown around quite often. And as we were, putting this together and, we're looking for information, even online, there was some miscommunication on what the differences were. So I think this is a great opportunity for us to kind of talk about it.
Mhm. So hot roofs are typically just they're unvented. They're completely fulfilled with insulation. Um, Cold roof is ventilated. I mean, it's just that simple. There's a spot in there to reduce the temperature, to flush the roof if it does get hot, which we see in the summertime quite a bit. Uh, Depending on the time of the year, a lot of times that roof is almost ambient. Of course, if the sun's shining summertime, that roof is going to be hotter, that attic will be hotter. Uh, Wintertime, it could be a little bit cooler. in the attic, depending on, again, the time of the day or the time of the year. But yeah, that's basically all it is. It's just ventilation. Um, the cool thing about ventilation is it works. It works in all the climate zones. And the way I look at it is you ventilate till you can't. And of course, there's obviously some situations where you cannot ventilate. It just won't work. You run into a hip, for instance. It's really hard to ventilate a hip roof compared to a standard gable roof. Um, Shingle manufacturers, some of them won't cover warranty on a unvented roof assembly. I don't think that's fair, but it's been in the codes for a long time, that ventilated roof, and it's kind of what they follow. We had an instance just this last spring where I was on a building investigation where we had a roof that we had some wrinkly shingles, and they blamed it on it not being vented, and it wouldn't cover warranty.
Yep.
So it happens.
When I think of that ventilation, I just think of a relief valve, and it almost when that heat is bringing in all that moisture, it gives it a place to go. The temperatures can reduce the shingle temperature, anything above that. It just kind of gives us a little security, if you will, knowing that we're kind of put that added step in there of ventilation.
Yeah, the biggest reason we ventilate is just actually to take care of our building deficiencies in the underside. We can't get it airtight enough. That attic or the roof, if it's completely airtight, there's no air leaking in there. The ventilation isn't doing anything other than, you said, flushing some heat out of there. There's no warm, moist air that's rising up into the attic assembly that needs to be cleared. So that, if you can get them airtight, it helps a lot. It'll take care of a lot of problems that we're seeing in roofs.
You did say the cool thing about ventilation. I caught that, by the way, when you said that. So yeah, don't think that just flew right on by.
As long as we're handing out flowers, I got to give Nick Stone credit. He did not use the word throttle. And I know he desperately wanted to when he was referring to modulating a condition. Good for you, Nick Stone.
Yeah,
You
pulled
know,
out the relief valve.
That's right.
these gray hairs are starting to come in, I'm starting to get a little wiser.
I love it.
But now we're going to start to transition a little bit into actually looking at some of these details, breaking them down and just kind of getting an idea of how you do it, some of the thoughts you have behind these areas. So we're going to start off with, what I'm going to call a flat ceiling or an unconditioned attic, where we're going to, have our thermal plane down here at the sheetrock level. We're going to have ventilation over the top of that. When I think of this, well, you know what? Randy Rand, when you see this, what are some of the things that come to mind when you see the ventilation part of it? Does this kind of make you nervous? Does this say I've done this, I like this? Walk me through some of this.
Yeah, this is a pretty traditional application because a lot of the stuff that we have going up here are utilizing trusses. And so when somebody is doing a truss roof, it tends to be that flat ceiling. What I've always found the interesting is that bottleneck right there down over the double top plate, right? And utilizing those higher heel trusses. So obviously that's step number one in what I'm seeing here. And the fact that the code will allow you to take a reduction in that R value across the roof if you can maintain that insulation all the way out over those top plates, I think is just like code showing you how important that one area is, right? It's super critical. So, but what I
And can
like, yeah,
and can you stop on the inside plate? When you say go to the plate, does that mean you can just touch the plate, or do you have to go completely to the outside?
right. Out over the entire plate, you've got to maintain that insulation value, right? So
Absolutely.
here it's choked down. So you would have to provide full insulation value across the roof that's specified prescriptively, in the
And the re
code.
and,
But
and so some of the reasons for that is because at a 45-degree angle, you could potentially get some cold coming through there.
right, yeah, those top plates are one, they are conductive all the way out. They're a thermal bridge, right? But then also just over the tops of them. You were just trying to get as much of that insulation value out over the entire wall. So
Sure,
that's the
absolutely.
Yeah.
goal.
And when you
But
don't accomplish that, you end up with ice dams.
right, second piece is that's what we have, and why I like this detail with your air sealing here. It looks like it's very well air sealed your channel from your soffit up above your insulation. You get all that air movement, but when you get that extra insulation there, plus that air movement, we can really prevent ice damming.
I thought to prevent ice damming, you put one of those heated strips up there. Is that not how that works?
How much
I
do you
can
like
show
paying
you,
for electricity?
yeah, I can show you all kinds of pictures. I've done energy audits where that's actually added $100 to somebody's electric bill in the middle of winter. I mean,
Mm.
that's a big roof and lots of heat tape, but yeah,
Right.
you don't want to go
So
that route if you have to.
right. So Travis, just kind of recapping here, what makes this here a unconditioned attic when it comes to a roof line, when it comes to that insulation layer up, call that the roof.
Sure. So unconditioned just is, in my mind, very simple because we're conditioning the inside of our space where we live and breathe. And we don't worry about conditioning outside of the envelope. That's outdoors. So if our thermal boundary is our ceiling plane, then anything above that thermal boundary, well, and I guess the actual thermal boundary would be the thickness of that insulation on top of the drywall. Everything above that is unconditioned space. And this becomes a huge deal if you're, say building in the South where they have mechanical systems that they like to put in their attics because they don't have basements. They're building on slab with post-tension cable because they're, well, soil conditions. And that happens in a lot of markets. It just doesn't happen in mine. I have basements everywhere here. We love a conditioned attic. I do not want to have anything inside of my envelope that is an unconditioned space if I can avoid it. We do conditioned crawl space, we do conditioned basement, and we do conditioned attic. What you have here is an unconditioned attic because there is no air seal, there is no thermal boundary at the back side of the roof deck below the ceiling. In our spaces, we love to do that. We love to have a conditioned attic instead because it
Yeah.
gives us a lot of freedom. And that's what you were trying to get me to lead into. So I think that's a high five. We planned that
You're
really well.
crushing it today.
Yeah.
Yeah, and then as we start to transition into, moving into the cathedral ceilings and what that kind of looks like, before we jump into this, one thing I just want to kind of mention here, that Randy alluded to a little while ago is where you are in the, in the country from a zone standpoint. This is really going to affect this one pretty dramatically. Once you start adding that insulation right up against the roof decks, and if because you could do an unventilated assemblies, or if you're doing an over roof system with ventilation, similar to what Travis did on his design. We have to start to pay attention to where these control layers are going based upon the zone. So kind of keep that in mind when for everyone listening. There are some quirks to some of this stuff, so we're going to speak kind of generically here. But Travis, when we start thinking about cathedral ceilings, where is that insulation located, and why are we doing that versus having the insulation downward? What are some of those benefits?
Well, there are many. My favorite benefit is that everything that we keep in our house, we wanted for a reason, right? Like we bought it, we made a person, we brought them into our home, we have a pet. Like everything inside of my house, I care about, and so it's odd to me that we would take a section of interior of the house, meaning underneath the water control layer of the roof, and go, I don't care about this part. It doesn't make sense when I look at it that way to not maximize the utilization of the space. All the architects in my market seem to love vaulted sections, even if the whole house isn't vaulted. Usually, the great room and the dining area and the kitchen will have a raised ceiling portion. So it's very common for aesthetic reasons to want to get as much of that low lid blown up and at the backside of the rafters everywhere that we can get it. So the aesthetic benefits are tremendous. The air quality benefit, um, I guess, could be mitigated one way or the other if you're doing air sealing at the lid. Air sealing at the lid is no different than air sealing at the back of the roof. However, when we talk about what Randy was saying earlier about the monopoly framing effect, where you have your air control tight from sheathing to your roof plane, to me that is so simple. It takes a lot of additional effort. I mean, Randy Williams has written a number of different articles on this that you can find at northernbuilt.pro, where he talks about different strategies for taking an exterior air control layer, bringing it across the top plate, and making it the underside of your ceiling frame so that you can have continuity to either use airtight drywall. All these different strategies become very simple when we just say, I'm just going to use the structure that is the roof for my insulation layer. We'll fill that up and we'll go ahead and make our air barrier there. And then if you've got an attic space underneath, like we had at the Fine Home Building House years ago, or in that Waldo house, we actually did have a section that we needed to run all of our Zender comfort tubes through. That comfort tube is the only thing that went in my attic space. So why would I not want the ERV ductwork to be in a conditioned space? I don't want that air to be heated and cooled multiple times as it moves through the house. I want it to remain at the constant indoor temperature that provides comfort to my clients and durability to my house. So those are some of my favorite benefits. I like a sound deadening because we do have a lot of storms here. And my clients not knowing that there was a tornado or a severe storm until they left the house the next day is
That's a
still not
benefit.
pride for me. So I can talk over roofs all day.
So those are just a couple of things that you like. Yeah.
Just a couple.
Yeah. Okay. I
Brevity
have
is my
a
strength.
I have a question that we get pretty often about this right here, the cathedral ceiling application. Oftentimes in that small space, it's hard to get the R value that you need to meet code, and we get asked about flash and bat systems quite a bit. I think that there's a time and a place for every system, every insulation and product. Do you guys, or is anyone willing to give a thought to a flash and bat system, or how that might be able to be applicable to something like this, or no?
I'm not a fan. I Unless we're going to do secondary framing. The thing about a flash and bat is that we're doing some mental gymnastics that I say play pretend. We're pretending that spray foam is going to act as a continuous air barrier when it's discontinuous. If we were going to do flash and bat, encapsulate all the framing members, and then do a secondary framing layer below that that wouldn't disrupt that continuity, I would be more willing. And if that's part of your framing plan anyway, because you need the depth, okay, then maybe you could do that, and I'm fine with that. But um, to me, the continuity of air control is the chief thing there, and the flash and bat is sort of a fool's gold when you just spray the inside of the cavity edge to edge. You haven't addressed any of the actual leak points, which are at the separations in the wood framing, the sheathing, and so on. Just my opinion.
That's
That
it's a fair take, Randy.
Yeah, that flash and bat system also it falls underneath that rule ratio again. So
Mhm.
you've got to have the right ratio of the spray foam to the fibrous or whatever you're putting underneath. If you don't do that, you will have condensation issues, or could have condensation issues on the surface of the interior surface of the spray foam, which then lead to what's called attic rain or dripping inside the house, especially in my climate later on.
Well, it's
The
something that we have to kind of tiptoe around, and it's like I said, there's a time and a place for everything. There is no magic bullet for every single application in every part of the country or every part of the world. So it's you kind of have to say, well, in theory, this might work, or in your area, this could be the best solution. But it's a question that comes up, so obviously want to address it. But I appreciate it.
Randy Rand, real quick, whether you're doing insulation like you did on your house, where you had insulation on the roof and in the cavity, um, do you when it comes to ventilating, would you ventilate that as the same as you would ventilate the picture down here on the left-hand side, where you just have cavity only insulation? Like, would you want to ventilate both options, or is there one that only you need to ventilate and then the other one you don't?
We ventilate everything, so we find our way to always ventilate a roof. So whatever system we're choosing to do, we make sure ventilation's part of the plan.
So it sounds like Randy Williams, ventilation may be important.
I would agree. Yep. Not only in the roofs, but walls. I like ventilated, the range screen, ventilated range screen walls as well. Yes, they're again, back to my comment, ventilate until you can't.
Yep.
Yeah.
Mhm.
If you
And then
guys are
let's
willing to stay a couple more minutes, we do have a slide on flat roof specifically. I mean, everything thus
Mhm.
far has been pitched, whether it was, your standard 212, 412, or a low slope, but we do have a flat roof that Nick wanted to talk about.
Yeah, so flat roofs is not always something that we, at least in the residential side, talk a lot about. Certainly more prevalent in the commercial side of things. But when I think of flat roof assemblies, I really think of three different ways to insulate those assemblies. So starting off with our first one, which is a cavity only insulation, where we're going to have insulation within our frame itself, some kind of plywood, and then a roofing material over the top of that. One of the certainly one of the concerns that kind of pop out right away is thermal bridging, through the frame. So some potential catch 22s there. But then we move into our diagram right here in the middle, which is going to be cavity insulation and exterior insulation. You kind of are putting the both worlds together, if you will. Again, going back to Randy Williams' concern, we just got to make sure our ratios are correct. That way we don't get any type of condensation forming. So we got to have to do the math behind that. But this is going to be, cavity between in the frame. It's in the cavity itself. Then we're going to have insulation on top of that, and then whatever roofing material. So giving us some flexibility there. And then we're going to move over to the right hand side, which is going to be exterior insulation only. So we're putting all of our insulation up on the top of the roof assembly. This makes me think of personally of glue lamps. If we're doing something with these beautiful exposed timbers, whether it's it could be solid sawn wood, it could be glue lamps, but just something where you really want to see that bottom of that structure. Maybe you have some V groove, 2x6 V groove pine or something like that for the roof deck, where it's beautiful and you want to see the grain pattern and the look of that. So when it comes to flat roofs, you do get some unique options, that are like I said, are more commercially, but certainly have some great places in the residential space too. Travis, you're kind of dancing on that flat roof category, if not in that category often. And having personally seen some of your stuff, it really does fit the bill of this residential build quite nicely. I think you would agree.
100%. Yeah, I haven't been able to sell a CLT project yet, but we did see a number of those in Switzerland, and actually a friend of mine's very active in Woodworks, which is an organization that helps flip projects from concrete and metal to wood. Uh, and this is something that you're going to see more and more in your multifamily, because you can get those roof assemblies up so quickly and have those really beautiful, as you described, Nick, beautiful wood grain interior, some surface mounted conduit. It's a peanut butter and jelly. Like, it's just so nice with some top rock on top of that CLT. You move straight to detailing your water control, and as long as you keep your scuppers clean, you've got a very high performing, low maintenance roof. I think EPDM is like a 50-year warranty typically. I don't know, Randy,
Yep.
maybe either Randy might know that better than I do, but I know that an EPDM roof membrane is far more robust and durable than, say, the asphaltic shingles that are common in my market.
So, when it comes to flat roofs, you certainly got a lot of flexibility there. You gotta love that. But we are kind of cruising to the end of our time here. So if we want to switch to the last slide.
Yeah, before we do that, I want to thank everybody for staying a couple minutes long. It was something that, again, we were talking residential most of the time here, but this is increasingly common in residential applications with the way things are being designed these days. Travis, do you remember when we did the sound webinar, I asked what the potential fifth control layer was? Do you remember what you said?
Well, I thought we were talking fire resistance, weren't we? Or was it sound? Oh, there it is,
I
fire.
I said sound,
Mhm.
but for next month, the hot topic is fire protection the fifth control layer? So you were out months ahead of where we were, but may have had an inkling it was coming.
I'm a visionary.
But yeah,
What
this
can
is
I
what we
say?
will be talking about next month. So again, I want to thank everybody for joining. Thank everybody for this, this panel here. It's a complicated topic that I think you guys made very digestible and made easy to understand. So I want to thank you all. And as a send off, Nick, do you want to do it?
Absolutely. As always, stay R classy.
Love it.
Beautiful. And I saw that there were some questions in there that we were not able to answer. I'll get back to you. We'll make sure that they get answered. So thank you all for tuning in. Thank you guys again for the panel here. It was awesome.
Thank you.
Thanks,
See you guys.
guys. Bye.